Okay, so once you find the moles of KMnO4, you'll substitute that into an equation. So, like if I had, I'm just making this up, okay? So, let's say I had 12 milliliters of KMnO4 that I added. And the concentration of KMnO4 is 0.025. So then what I would do is I'd make this liters, and I'll just go 0.012 liters of KMnO4. Then I would say that for every 1 liter, I have 0.025 moles. So then my answer on this would give me moles. And I would do that with all my examples. If you guys want to take one of them out, or average them all, or just take one of the three, it's really up to you how you guys want to do it. So it's 0.0030 moles. I could probably take that out a little bit further because I think my volume would have been 12.0. So yeah, let's just leave it at that. Okay, questions? All right. Then the next step that I'm going to have you guys do is when you look at the front equations, you've got MnO4 plus 8 hydrogens. This is the hydrogens that come from the sulfuric acid. So this reaction has to take place in an acidic solution. So that's why you had the H2SO4 that you had to add. When you reduced it, the magnesium became manganese plus 2 plus 4 H2O. So what you're doing is this is a plus 7, and then it's going to a plus 2. So this is a plus 2. I'm going to write that again. So you're adding electrons to it, okay? Where's those electrons coming from? They're coming from the h2o2. So above that, you have h2o2. So above this, you have a reaction that would be H2O2 is going to go to O2 plus the 2H plus the 2 electrons. Okay, so first thing I'm going to have you guys is balance the electrons in both reactions. So what I want you to do is I want you to figure out how many. These are called half reactions. You may know what this half reaction it is. This is going from hydrogen. It's going from oxygen that's a -1 to oxygen that's a 0. So it's going from -1 to 0. What's taking place there? Is it being reduced or oxidized? Oxidized. So this is the oxidized half. So this is being reduced, right?
Yeah.
Okay. If this helps out, no, we'll just do it the half reaction way. Wait. So if you divide them up into half reactions, so all those reactions we did all together, you can divide them up into half reactions. One's oxidized, one reduced. So what do we need to do to this one to get the electrons to balance? What do we got to do to it? Multiply all of this by what? So this one down here, this one has 5 electrons, it's gaining, and the other one is giving up 2 electrons for every time you have a molecule of hydrogen peroxide react. So what do we got to multiply the top one by? By 5. So we got to multiply everything by 5. So it becomes 5 h2o2 arrow 5 O2 plus 10 H plus how many electrons? 10 electrons. I'm going to have you guys do the bottom one. So you guys do the bottom one. This is another way you can balance reactions out to where it's not all one reaction. It's called a half reaction method. So did you guys multiply that by 2?
Yeah.
Okay. So everything multiplies by 2. So we got 2 MnO4 plus 16 H plus 10 electrons gives us 2 Mn plus 2 plus 8 waters. You guys have that? Okay, I'm going to cheat, and I'm going to do a little racing here. So we got those 2 half reactions. Now, if you combine the half reactions, then what you end up with is an overall reaction that's balanced. And we've taken the spectator ions out. So like the sulfate in H2SO4 was taken out. And you don't see that because this is kind of like a net reaction, where we don't show spectator ions. Okay. So then what we're going to do, I'm going to have you guys do this, is we're going to combine both reactions, but where we need to cancel out values, we're going to cancel them out. So you guys see anything, it cancels out right away. So we're going to add these 2 reactions. So we're going to add these 2 reactions up, and we're going to go ahead and find a final reaction that's balanced. So what can cancel? The electrons. Remember, that's what we were doing in an overall reaction. We were trying to get them balanced, so they're balanced. What else? What else is on either side that we can cancel out some things?
Does it matter? Like, do they have to be the same? Like, there's 5?
They have to be the same to cancel out.
Okay.
But they don't have to be the same number to cancel out.
Oh, so we can.
So what else can we cancel out? Some of them.
We could do the 16H and the 10H.
Yeah. So if you see the 16H and the 10H, well, 10 of those 16 are canceled out.
Yeah.
So you'll cancel out these, and you'll be left with 6 H plus. Right?
Mm-hmm.
Is anything else canceled?
So,
I don't think so.
because that's H.
So then what you do, rewrite this equation up above. So combine anything on the left side of the arrow, right on the left side of the arrow, combine up above. Anything on the right side of the arrow that's not canceled out, right above on the right side. Go ahead and do that.
Doesn't matter which one goes.
It doesn't matter as long as they're on the left side or the right side.
Okay.
So you should have written So if you put in extra of the MnO4, it goes back to that deep red color. Does that make sense? So you're putting it in, it's clear, 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 and then when you get it perfect, you make the Mn plus 2, and that color is pink. And then if you put an extra couple drops in of MnO4, then you went past the point, and now no longer is it pink. So that's what you got to guard against. So you guys, so then when we take a look at our information, I had 0.03 moles of this. You guys have something different, right? I think I had 0.03. No, I had 0.003. I'm sorry. 0.003. That's of the KMnO4, so it's the same as the MnO4. So now, this is what you've got to do, is you've got to find out how many moles of H2O2 you had. So, you guys do your mole ratio. So figure out how many moles of H2O2 you had. Mine would be 0.0075. Okay? Now, if you're doing multiple examples and you want to do them all separate, that's kind of up to you what you want to do. But this we would take the 0.003, my example anyway, moles of MnO4. And you say for every 2 MnO4, you have 5 H2O2, and mine would be 0.0075 H2O2. So this lab, our thing we're trying to do is find the concentration of hydrogen peroxide. So concentration of hydrogen peroxide would be percent concentration. So we're looking at trying to find the percent H2O2 that we have combined with water, because it's diluted down. So, and you're going to do it by mass. So find how many grams of H2O2 you have. So go through and calculate the grams of H2O2. That would be your next step. Find the grams of H2O2. When I did mine, I got an answer of 0.225. So I had 0.25 grams of H2O2. Okay? What was the total volume of the H2O2 that you put in? 0.001 milliliter, right? Or I'm sorry, 0.001 liter.
Yeah.
But you had 1 milliliter of it, right?
Yep.
Okay. So the density of that solution, you can follow. So the density of the H2O2 is roughly 1 gram per 1 milliliter. So how many grams in total did we have of the solution? So we had 1 milliliter of it. So how many grams did we have of it? 1. Okay. So what I come up with is 2.5%. H2O2. What'd you guys come up with?
Six.
2.6.
2.7.
2.7. Anybody else? You got 2.5. 2.53? 3.5%?
Yeah, I think that one.
Did you, how much did you add here?
I think that was the one I added a little too much.
Okay. So you probably want to use one where it kind of turned pink and you know you measured things out right. So you can throw things out. You don't have to average them. You can throw them out. The stuff I gave you was approximately 3%. So the hydrogen peroxide I gave you, it probably, as hydrogen peroxide sits over time, it gets weaker. So I could see that that's probably a pretty good logical answer if you had somewhere between 2.5% and 3%. Because it probably decomposes. I took a sample from a year ago and it will decompose. It just self-decomposes.
Closest I got to that was 2.98.
Yeah. So you guys can use this method to tell concentrations of different things. You don't just have to do concentrations of acid, but what this allows you to do is called oxidation reduction analysis of hydrogen peroxide, and you can figure out the percent concentration. So it's kind of a neat little thing that you can do. I knew it's something I needed to go through with you, so there you go. We'll just have you turn that in for some credit. You see your work and that there. And then tomorrow I'll give you guys a review of the chapter. So you just put your name on it, you show all your work and that. I'll give that back to you later and I'll grade that. Okay?